Okay, so then let me start. Uh, Today, I'd like to introduce the company Saralon, and also I'd like to give you let's say, a quick overview about, let's say, what printed electronics can do in the near future in quite a different areas of applications. And but before I come to these areas, I'd like to give you a quick history, let's say, about the company itself. So Saralon, the company, I'm one of the co-founders and managing director in charge for sales and marketing. And the company itself got started 10 years back from an institute of printed electronics here in Chemnitz, located in Chemnitz, Southeast Germany. And Saralon, over the years, has developed quite a range of different functional inks, from copper inks, water-based copper inks, or polymer inks, carbon inks, and a set of functional inks based on silver particles. And yeah, we have over the years launched quite a range of different, let's say, applications, or we work with companies. They use these inks to develop different applications. But the ink is only one, let's say, side of the medal. And because what we also supply is we provide, we call it process know-how, because we saw there is a lack in the industry supporting converters and the companies who would like to start in the field of printed electronics. And so somehow to overcome all these, let's say, painful process, learning it the hard way, Saralon provides, we call it the process transfer. We enable companies to produce printed electronics in-house. And yeah, I think it's so far it's quite successful. What you see here in the video, it's just an example printing, a fully printed battery with our ink set. And this is done by one of our partner companies or customers in Netherlands. So it's quite simple. If you know how to, let's say, handle the process, and you have the right set of inks, you can easily enter such a new emerging technology. And this is what Saralon does. We enable companies to enter that thing and not being afraid of all, let's say, the hard R&D or all the painful things. So this is more or less what we call ink tech. So it's not just the ink, it's also the process. So, and now I'd like to address a few areas where you can use our inks and to simply enter some emerging new technology fields. So today, I'd like to cover our solutions for stretchable electronics, for in-mold electronics, then some printed sensors, and finally, I'd like to highlight our solutions for heating elements. So there's quite a number of, on the left side, you always see some key application areas that we consider, let's say, in the future becoming some hot topics and some very growing markets, such as smart textiles or wearable applications, either in sports or medical areas, or the automotive interior sector. Yesterday, actually, we attended an automotive interior show in Stuttgart, where we also presented some solutions for, let's say, some detection, some methods, and because it's also a very growing market. So that's why, these markets, they require certain, let's say, properties, or they have certain requirements in terms of stretchability, applying forces to the inks, and so on. And that's why Saralon developed a set of stretchable inks, either to be printed directly on textile or to be printed on plastic or to be printed on paper to, let's say, fulfill all these requirements, but on the other hand, also maintain their functionality. So, and currently we are running, let's say, some joint developments and also tests with quite some big players in the industry and some institutes to get some feedback about the performance of the inks and to further develop it. And then also jointly to develop final applications that can finally solve some issues and some demands in the market. Here, as I said, you just see a few, let's say, application areas. The next area I'd like to highlight quickly is it's so-called in-mold electronics. So what's the difference between stretchable inks and, let's say, inks that can be used for in-mold electronics? The difference is, instead of applying the inks on a stretchable substrate and then later on, let's say, applying these or gluing this substrate into, let's say, plastic housing or so, here you actually apply the inks on a substrate like polycarbonate, and then you finally do a thermoforming process, which means you apply some pressure and heat, and then the inks actually, the surface itself becomes a three-dimensional surface, but still the functionality remains intact. So we which means you create a three-dimensional smart surface instead of applying some two-dimensional substrate into another surface. So this is quite a revolutionary process, and Saralon offers two inks, let's say, that can fulfill or that can be used for such process. One is our copper ink, and the other one is a stretchable silver ink. And currently, again, we are running some tests and we are doing some joint developments with some big players, identifying spots and also creating some final applications. And but it seems quite promising. We have created some working samples, even including SMD components in it, and then doing a thermoforming process. And as I said, the outcome so far seems quite promising, but we just started the journey. So I think we are still, let's say, at the very early stage when it comes to that. But there's a lot of application areas like HMI electronics and so on, where we see there's a big potential for these solutions. The next topic is, we call it printed sensors. So printed sensors mean you can actually use inks to do a certain measurement, let's say, functions, which, for example, you can, let's say, print the inks like a pressure sensor, and you apply them in a shoe, and then to detect some pressure, some dots for diabetes patients and so on. Or you can do the same to monitor the cool chain along in the pharmaceutical area, in the supply chain of packaging. So there's quite a number of different use cases for that. And that's why Saralon offers three types of printed sensors here. We have a pressure sensor, ink, which is piezo-resistive approach or principle. We have some humidity sensor. We have temperature sensor. On the right side, you see also, let's say, the specs about them. But normally, when we start doing some development, some joint development with companies, they normally approach us, and then we specify or modify our inks according to their special needs and requirements. So the specs you see on the right side, these are more our standard, let's say, numbers, but then normally we go on a journey together with them, and we develop a more customized product. And finally, just to identify a few areas, I'd like to highlight another hot topic these days, and which is called printed heater. And here you see a few application areas, especially for electromobility, because normally for the old, let's say, fossil fuel engine, you could use the heat as a side product from the engine, which is not possible these days from, let's say, from electrical cars, which means you have to really create the heat on the surface directly. And therefore, let's say, with our printed inks in combination with some stretchable inks, you can really apply the inks on almost any substrate and then you also for medical applications or wearables, but we see a huge potential, especially in automotive interior. And again, here's the same. So normally we have a standard range that goes up to 100 degrees, but then normally our clients, they approach us then, and they have them special needs in terms of temperature window and so on. And then normally we can then do some adjustments on the ink to fulfill their requirements. So these were just a few areas where, let's say, we provide some solutions based on our ink technology. But there's one big thing I'd like to highlight here also. It's not just, the solutions or the application areas we can enter with this thing. There is also one thing, comparing printed electronics with, let's say, existing technology, mainly conventional electronics, because conventional electronics is mainly based on PCB technology. And this PCB technology is you can say a very nasty business when it comes to the production, because it's normally an etched out circuitry. So you need corrosive materials to etch the silver or the aluminum from a certain material to create a circuitry then. And you have a lot of, let's say, toxic waste and a lot of side products here. While printed electronics is an additive manufacturing process where you apply only the inks at certain spots where you need them. So the amount of ink you need is far less, and there is no such nasty side product. Our inks, for example, have no toxic or corrosive materials in it, and it gives you also plenty of design freedom in terms of you can print on flexible substrates, you can integrate them into three-dimensional structures, and so on. So all I'm saying is it opens up by far more opportunities, and and it allows also decentralized production. So there's no need just to produce that at one spot in the world. So actually any printer in the world having maybe flexo or screen printing, they can actually do the production directly at their place. So there's no need to outsource this thing to some certain centralized places, just saying. And that's the beauty of printed electronics. So a quick wrap up, what Saralon offers. So as I said, we have a range of different functional inks. We branded them at Saral Inks. We call the process, or we call the whole thing we offer, not just ink, we call it ink tech, because we also enable converters to use our inks and to integrate them into their process. We also, let's say, provide, we call it print decoration, a set of different inks. For example, I showed you in the beginning the printed battery. The printed battery consists of 7 different inks. And there we have developed a set of inks that allows you to print a battery completely. All layers are fully printable. And we, let's say, provide this as so-called starter kits. So we enable here also converters to easily start in battery printing. And they don't need to learn it the hard way, because they get everything from us from one hand. So easy scale up. I mean, I have shown you some cases where you can use that in the future, and all these markets, I think they have a huge potential. And yes, Saralon also offers a lot of R&D, let's say, competence. So normally we do joint developments together. We also write public proposals, or we are part of these public funded projects. So whoever has some good idea and wants to, let's say, develop some groundbreaking new stuff, they just contact us, and we then, let's say, help you in the best way we can to develop your desired application. So this was just a quick, let's say, journey about Saralon and what we have to offer. I hope, it was understandable, and feel free to ask me questions.
Thank you very much, Steve, for the presentation. Now we go to the Q&A session. So the first question is, they want to know about the biocompatibility of the inks for bioelectronic applications.
Yeah. Okay, so I can just tell you, there was one example that I have also shown in this presentation. It was related to inks that can withstand bending. It was one of the stretchable inks. For example, we have developed inks printed directly on the paper. Also, then they can survive the creasing line, the bending, and so on. And we also currently working on a printed battery that is not, let's say, normally the printed battery is using a PET foil or a blister foil as a, let's say, a barrier layer. But we are currently working on a battery that can be fully printed on paper. It's a special paper, so that means you can actually use that, and after, let's say, end of lifetime, you can easily dispose it then. But yes, for now, all our inks they have no toxic materials in it. They have no corrosive materials in it. So we really, let's say, we really focus on that. There's no nanomaterial stuff in it. But at the end of the day, I mean, a battery is a battery. To be honest, we are discussing this also with regulatory institutions. But for now, you have to dispose it the same way, for example, like you dispose a conventional one. If this answers your question.
The next question is, what is the...
I'm sorry, I lost you. I'm sorry. Can you please repeat it?
What is the maximum temperature that your inks can be heated to?
This depends, actually. You know, I know some inks, they require sintering. Actually, in our case, it's normally around between 90 and up to 120 degrees. But to be honest, we can also, I think for some inks, maybe like the copper one, you can also consider sintering, but our inks are developed for low temperature curing. Mm-hmm.
So I'm not sure if the question was a temperature that your inks can withstand. So
withstand.
What kind of environment?
That's a good point. Sometimes I would say, yeah, it depends. You know, like I said, our portfolio, let's say we have copper, we have polymer, we have carbon, we have silver. It depends a bit on the use case. I mean, we had inquiries, let's say, can the ink withstand in long term 400 degrees? To be honest, it requires some testing. So I cannot let's say, deny, or I cannot just confirm it, let's say it this way. So we have to do some testing. It's hard to say, to give you a limitation. I think I need a proper case, and then we have to check the particular ink for it. as I said, we have 35 different inks in the portfolio. Just saying they can always stand up to this, it's a bit difficult to say. What are the changes for electroluminescent?
So you have 35 inks in the portfolio, and the next question is, what type of inks do you make? Gold, silver, platinum, or etc.
No, we make. As I said, we started mainly with silver-based inks, carbon-based inks, and polymer. And around 2 years back, we launched our first copper-based ink, a water-based one, as a copper ink, water-based one. And so, yeah, over time, we increase our portfolio, also depending a bit on the, let's say, customer inquiries and demands. Yeah, but yeah. So these are the main inks. We are not dealing with nanoparticles. We are not dealing with gold. We are not dealing with any other than these four, particles.
Okay. So are these inks inkjettable or a screen printable paste?
We have our main inks, or let's say, I would say most of them or all of them, they are designed for screen printing. We have also developed one ink, a special one for flexo. But our range is mainly designed for screen printing. Yeah.
And what is the sintering mechanism? Is it only oven-based, or do you also do
Oh, it depends. We have UV curable ones, we have thermal curing ones, so this depends. But as I said, none of our inks is designed for, let's say, high temperature curing like sintering. They are normally around 90 to 120 degrees, let's say, thermal curing, mainly, or UV. Yeah. I was just reading one thing. What are the changes?
Is the screen print?
Yep. I'm sorry.
We'll get to all the questions. So I'm going through the questions one by one. There are many questions, so we'll get to that question too. So, so is this screen printable ink, the silver/carbon ink, is it easy to clean after printing, and what kind of solvent will be used?
Yeah, that's also a good question. Again, I need to, let's say, normally what we do is actually, because all these questions they come when we get approached. That's why we provide a specific data sheet with it. We recommend certain cleaning solvents also depending on the product, because we have a printing unit in-house where we do all the product development and testing, and then normally we recommend what we consider the best in terms of cleaning the screens and so on, and also with less side effects like the smell and all these things. So, but this you find all in our data sheet. So I cannot go through the entire product list, but I can assure you, for example, when you reach out to us and you place some order, you have some request for a particular ink, we normally share the data sheet and you find all this information. The noise is really a bit irritating, to be honest, because whenever somebody joins, I have it in my, anyway, just saying.
I know. So if you click, maybe take a moment now. So you see your own name on the top right. Just click on that, and then you can turn it off. Okay. So you see a little on the top right. You see your own initial. Click on that. And then
now I got it. I'm sorry. Yes. Yeah. Because I was a bit irritated. I'm sorry. Yes. Please go ahead.
I understand. It's every time somebody enters the room, you hear it. So the next question is, how do you ensure adhesion of printed material to the substrate?
That's exactly it. This is also a very good point. I can assure you, over the years, I'd like to show you one thing. For example, this is a textile, and this is one of the stretchable inks we have developed for the textile. And there is no penetration through the material. This is one example. I can also show you quite a few others, like on TPU or so. What we normally do is we test on different substrate. Either, let's say, the customer, they approach us and they send us the material and we do some trial print and we do testing, or during product development, we test them. As I said, we have a print unit here. We test them quite on different materials to identify, let's say, adhesion works best on this and this and this, or to modify the ink. So that's quite a challenging process, because, we know that these days, let's say, there's a lot of materials out there, especially when we talk about stretchable ones, and adhesion plays a major role, whether the inks perform well or not. So I can assure you, we do a lot of product testing. We do a lot of material testing here to recommend some substrates where we know for sure it will work. Or if we have not done any testing, we normally ask then the client, please send some stuff over. We do for free some test print, and then we give you the results, or you can do your own testing on it before we even, let's say, move on then in the process.
So Steve, we have 4 more questions. We go through them quickly, and then no more questions from the audience at this point. But if somebody does have further questions for Steve, you can meet him at the break. So the next question is, what are the chances for electroluminescent inks versus printed OLEDs or LED integrations?
In which way? I think here we just need to talk about, or let's say we have to clearly specify the application. I think this is a topic, especially when we are dealing with for quite some time. I usually say all these 3, let's say it's either LED, it's either OLED, or it's either EL. They have their, let's say, perfect use case scenario, I would say. But I cannot, but they have their pro and cons. For example, I think most of the guys here in the audience, they might know, when we talk about EL, we normally talk about inks, they require high voltage for activation. So that means I would probably not consider them for some items like a bottle label or so, at least not integrated all the electronics in one piece, while the OLED, it's quite thin, it's even flexible. Together with our printed battery, I can show you one sample of that. It has absolutely is, let's say, this is a development we recently developed. So this is the OLED label here on a flexible substrate. You just laminate some graphics on top and you have a flexible OLED label. So this is meant for, at least in this context, for more use and throw flexible item. So it all depends. But then when you see that more from a price point of view, I mean, then it's a different discussion. So all I'm saying is, I think EL technology, maybe when it came out, people, they had high expectations, but then over the years, maybe they learned it a bit that there are some side effects, like I said, high voltage consumption and so on, and also AC/DC inverter that is required. And the bigger the display, there is a tendency that the displays, they might heat up and so on. So it totally depends on the application area, I would say. I think he left, or?
Sorry, I got kicked off for a second, so I'm back.
Okay.
Can you hear me now?
Yep.
So the next question is, what is the cost of your silver? What is the best conductivity you can get? And what is your shelf life?
Yes. So normal shelf life, let's start with this, is normally, even though internally, of course, we use that longer than that, we test a lot, but normal shelf life, when you buy the product, it's around 6 months, it's standard. But of course, you can use it longer, but we have to give an expiring or shelf life date. So it's an average normally 6 months. So the secondly was, I think the price totally depends on, let's say, what kind of ink we are talking about. At least, I think we have silver-based inks, we have UV, we have a high solid content silver ink, which is designed for high conductive products such as antenna printing. We have 3 different stretchable silver inks. We have a water-based silver ink. So long story short, depending a bit on the application. And I cannot talk about pricing in detail because we have some distribution partner in Europe, and I cannot talk on their behalf. But I can assure you the prices are, depending on the ink, they are feasible. And normally we offer them in very low quantity in the beginning. Normally it starts with 250 grams. So you can easily do some trials, some performance tests, I think, and then we can discuss, let's say it this way, if there's a certain volume behind, of course, we can discuss everything, and pricing, of course, as well. And highest conductivity, to be honest, good question. I need to check that, but it also depends a bit on the product. We have, for the stretchable ink, we have designed a special page where we actually also show, depending on the stretch level, the development or how the resistance level changes. So I usually stick to, you tell me, let's say your use case, and then I recommend the product, and then I can give you all the specs. This is easier than just picking out one product out of the let's say portfolio. Yeah. I hope.
Great, Steve. There are more questions, but we have to stop here. So Nilesha, Haridos, Tommy, and Mike, I haven't read your questions out, so you can meet Steve at the break. Yep. He will have a little booth. He'll be there. So just jump into that room and talk to him directly with, about your question. Because now, we have to move to the next stop. But thank you so much, Steve, for joining us, for being patient and answering the questions.
No, thank you, guys.
We really appreciate it.